All right, I wanted to talk about section 4.1 a little bit. This is going to be where we're headed in probability distributions, and we've worked on them just a tiny bit. This one is going to be the uniform distribution. So, a few things to note about the uniform distribution. In general, we've had the standard normal curve, right? The uniform distribution is going to be specific, but I'm going to do some generalities here. It might even help us with some of the binomial distribution stuff people have been asking questions about. Anyway, so if we have a probability distribution, we have a curve, and usually this curve has some kind of function to it, even if we don't necessarily know what it is. We call that the probability distribution function. And the probability under the curve is going to be 1. That's not new news. That stays the same for most of our distributions. A couple of things to note. Outcomes are, they're measured, they're not counted. So the area under the curve here is 1. And that means we can't really find probabilities of like 1. Like I can't really find the probability of this because it would be kind of like a line, but it wouldn't really have any area. So that's what this part here is saying. The probability of x equals c is going to be 0. We're always going to be concerned about when it's between a couple of values. So again, this is a distribution. We call the function that makes the curve the probability distribution function, and then we call this little chunk we'll use a cumulative distribution function to find that probability. So in a uniform distribution, this is the way we annotate our probability distribution function. We say x tilde, and we have a u here. It's a uniform from a to b. So a is the lowest value and b is the highest value, and we usually just do those kind of like on a number line like you would right here. There. Because it's a uniform distribution, it is equally likely that each event occurs, which means it's going to be like a rectangle. And so the height of it is going to be 1 over b minus a. We always like knowing the mean and the standard deviation as statisticians. And so the mean is really the midpoint here, a plus b divided by 2. And the standard deviation gets a little wild here. We have the square root of b minus a quantity squared divided by 12. And again, all this stuff here is inside the square root. So I stole a snip of a question here to work on. It says the time it takes to wash the dishwasher the time it takes me to wash the dishes, is uniformly distributed between 11 and 20 minutes. What is the probability that washing the dishes tonight will take me between 15 and 17 minutes? Give your answer accurate to 2 decimal places. I'm going to ask you to draw here. So if I go to this home thing, if you don't have the draw here, you'll just kind of go to the ribbon. This is the way I do it anyway, and you might have to click this. If I do this, the draw will be gone. If I do it again, I can bring it back. So customize ribbon, add the draw you want there. You want to be able to draw. Now hopefully it works for me. So I want to draw here, and I've got a little stylus. I'm not going to be super picky about the drawing, so if you just need to draw with the mouse, it's okay. But the time it takes me to wash the dishes is uniformly distributed between 11 and 20 minutes. And so I'll just draw myself a picture here, and I've got 11 somewhere and 20 somewhere. So it's going to be a rectangle, something like that, and the height here was 1 over b minus a. And what you can think here, from 20 to 11 or 11 to 20, we take this one and subtract this one. We take 20 and subtract 11 to get the width. Since the area under here is 1, we know the length times the width equals 1. The width, really stellar penmanship here, is 9. So this is 9, which means the height is 1/9, because 1/9 times 9 gets me 1. So that's where that b minus a and all that business comes from. Okay, so somewhere in here are 15 and 17. 15 and 17. Maybe I should get rid of that 9 now. And so we're looking for this area right here. Okay, that was all the quick little scribbles. Again, I really do want people to draw the distribution. because it really helps with understanding. And I know that this is pretty simple right here, or it may be for you, but not always for everybody. So anyway, okay, we had A was 11, and B was 20, and then the height is 1 divided by 20 minus 11 here. And I could click on those cells if I wanted to. This is 1/9. I'm going to show you how we got this. I'm not really necessarily looking for you to show this kind of, I mean, like you'll have it in the cell here. You don't need to copy this over. This is just so you can kind of see what I'm doing. So then the area between 15 and 17, the probability that if we go from 15 is less than x is less than 17 is going to be this width right here. So 17 minus 15 is 2. Times the height. So this is our probability. We've got 0.222, and this is rounded 2 decimal places. So 0.22 is going to be our answer here for the probability. So you're kind of drawing a picture, doing a little bit of work to find the height, and then we'll find the area there. If you don't know where the 2 came from, it was equal to the 17 minus the 15. When we want to find out how wide an interval is, we'll just take the large one and subtract the small one. There. So there is a little bit about uniform distributions, kind of how to draw a picture, and one problem worked out. I'll probably stop this and try to do a couple more examples in a follow-up video. Thanks for watching.